Oh, goodness, excuse me. Here's your warm-up, guys. Simplify these expressions using multiplication. We're working on it right in the middle of it in class. Let's get to it. Here we go. Yeah, you'll want to pause the video and let's do this thing. Okay. Can I get you guys back in up here in 5, 4, 3, 2, 1? In case you guys are wondering about the pictures that are always going with these, it's since they were talking about power expressions, it gives me an excuse to talk about the superhero that has my favorite superpower, which is this dude right here, Matter Eater Lad, whose power, as you might imagine, is that he can eat any matter and digest it. And there's just like, it's so dumb watching them try to find ways to make that work. Also, P.S., look at this guy. He's like, we'll have to let the crooks go while we save our men in the ship. Quick, use your superpowers, Matter Eater Lad, Phantom Girl, and the rest. Number one, the rest should be like, oh, ouch, excuse me? Also, P.S., where's that one going? Or maybe he's the bad guy. Oh, that makes sense. He might be the bad guy. I like that. Anyway, let's see what we got here, guys. So, let's see. There we go. If I have c to the 31st times c to the 43rd, I've got a grand total of how many c's multiplied together, Juliet? How many of us got c to the power of 74 for our answer there? That's exactly right. C to the power of 74 is precisely right because I just have 31 c's and 43 c's, which is a total of 74 c's. Now for this next one, yes, Jack?
I have a question. So, isn't it like if there's another c times c, which is the same thing as c to the second power, don't you just add another power?
I don't know. You mean like if I had another c like this?
No, because I
can't hear. Oh, no, it's not. And I'll tell you why. If we take these numbers down a notch, like instead of c to the 31st, I take it c to the 3rd, times instead of c to the 43rd, I take it to c to the 4th. How many c's am I multiplying here? Oh, no, just right here, Jack. 1, 2, 3 times. How many c's right here? 1, 2, 3, 4. For a total of how many? Yeah, see, there's not an extra one anywhere. It's because this is telling you, and the thing is because everything's got a secret exponent of 1. So when there is no exponent, there's there's that extra 1 that you're thinking about. This is 3 c's and 4 c's. This is 31 c's and 43 c's. Great question. Love that. Okay, for this next one, guys, this is a little bit trickier because it's got like blank x to the blank. But what is that going to wind up being? Let's see if I can get a little bit of help. Anaga, how many x's do we have? Let's start with that. 16 x's. Okay. Up. And then what is the number right here? 10. Now, I know that Eden got a different answer. Eden, what was your answer? Tell me what you got first. Yeah, because I think it might be. That's okay. That's okay. Keep going. 7x to the what? Okay. Here's the fun thing, guys. Anaga and Eden are both getting half credit for this problem because they each have one box that's incorrect. Will you talk to each other? What was Anaga's mistake? What was Eden's mistake? And how can we do this right? Teach! Okay. All right. Can I get you guys up here in 5, 4, 3, 2, 1. Okay. Let's see here. Voices, please. Crystal, what was Anaga's mistake? That's right. There's a secret 1 right here. So we've got to make sure we do 9 plus 1 plus 7. So that should really have been 17, which Eden got correct. However, what was Eden's mistake, Aria? And why did you get 7 instead of 10, do you think?
Because you're supposed to multiply.
Yeah, the 2 and the 5 are the coefficients. And since they're coefficients and not exponents, we don't add them when we multiply them. We just multiply them when we multiply them. So that should have been the 10. I actually love it when stuff like that happens. That's beautiful. Because how many of us feel like we actually understand that just a little bit better having seen that? You see how helpful that was? Absolutely. And not just for the people involved. You love to see it. Let's see here. Essie, this next one, it's you. This is going to be something, Q to the something, R to the something, S to the something. What would you fill in the coefficient with here, Essie? I'm glad we're talking. Let's focus on the Q's then. How many total Q's am I multiplying together? Oh, okay, hold on. You're just answering me here. Never mind. You're doing the harder part first. I love it. That's great. Now tell me about the Q's. What would the Q's be? 9. Very good. How about the R's? Let's see, because we got 5, 6, 7, 8, 9, 10. Totally agree. How about the S's? Agreed. 13. How many of us either got that or see how we got that and aren't too alarmed? You guys doing okay out there? Yeah. Beautiful. You love to see it. Let's see. It is the 52nd day of school. Since 52 is not the sum of any number's proper divisors, it's an untouchable number. I think it might be easier to explain what isn't an untouchable number. So somebody give me a number between, I don't know, 10 and 100. Go.
30.
30. Okay. The proper divisors of 30 are all the numbers that go into 30 other than itself. Go. 1, 2, 3, 4. No, 4 doesn't. 4 doesn't. 5 does, though. 6. Nope. 10 does. 15. Can't be itself, I'm afraid. I think, is that it? I think that's it, yeah. So if we add up all of those proper divisors, that's going to be, let's see here, 25, 14, 3, that's 17, plus 25, which is 37, 38, 39, 40, 41, 42. So 42 is not an untouchable number because it's the proper factors of 30 add up to it. What I'm saying is there's no number you can take the proper factors of and add them together to get 52 in the whole universe. Happy National Sandwich Day! Yay! Hang on a second. D4. Samuel, what's your favorite kind of sandwich?
Just like a classic, just
turkey. Turkey sandwich? Absolutely. Leo, what's your favorite kind of sandwich?
Either green Samuel or a bacon lettuce.
Oh, BLTs? BLTs are bomb. I love a BLT. Let's see here. And then Eden, what's your favorite kind of sandwich?
I like turkey and cheese.
Turkey and cheese, absolutely. Can I tell you what my favorite answer to this question all day has been? It was the first time I called on anybody today. I call on this girl, she sits at B3, and I'm like, all right, Ava, what's your favorite kind of sandwich? And she goes, ice cream. And I was like, that is a really good answer to that question. How many of us, the next time someone asks us what our favorite sandwich is, are just going to say ice cream? Yeah, absolutely, because you guys, ice cream sandwiches are so good. Okay, let's see here, guys. What is our first essential question? And I'd love to get that from Sir Truman. Awesome. That's the first one. How do we divide power expressions? There's a second one today that I want you to write down. What's our second essential question, Bennett?
Second essential question is what do the weird results we get there even mean?
What do the weird results we get there even mean? Because I'll tell you, those tend to go a little bit off the rails. Vice presidents who became president Serving as VP for Barack Obama from 2009 to 2017, he himself ran for president later and held the office from 2021 to 2025. That is indeed Joe Biden. And then classic American dining food is, do I see it up there? I know, I'm sorry I drew that funny. Oh, you guys didn't put the real answer, though. That makes me sad. That means that a bunch of jokesters just blocked it from people putting the real answers. Oh, well. I was going to have a whole big conversation with you guys about who makes the best fry sauce, but if we're not going to actually do it, then we're not going to. Sorry, guys. We're actually not going to have that conversation because I can see that some jokesters blocked the way so that people who really wanted to answer it couldn't, and I hate it when that happens. Got a pencil? Okay, dividing power expressions. Right to it then. Dividing power expressions. Maybe spend less time blocking it from people who really want to do it and more time just putting your dumb joke up there and sitting down in your seat. Okay, let's see here, guys. Let's start easy. G to the 9th divided by G to the 4th. I'm just going to divide these power expressions, okay? G to the 9th divided by G to the 4th. Now, G to the 9th, what does that actually mean? Elin, what does G to the 9th actually mean? It's 9 G's multiplied together. So let's go ahead and write that out in the numerator. 1, 2, 3, 4, 5, 6, 7, 8, 9. Elin, what does G to the 4th mean? Yeah. Now here's the thing. We don't know what G is, but as long as G is not 0, more on that later, we know that they can divide out, right? Because they have factors in common. They've got a lot of factors in common, right? All those G's divide out, and the numerator becomes, well, 1, 2, 3, 4, 5 G's, and the denominator becomes 1, because remember when everything reduces like that, it turns into 1, which is really just a fancy way of saying G to the 5th. When I say teach, I want you to say, okay. Anybody notice a shortcut that actually makes a whole lot of sense if you think about it? Teach! Okay. Can I get you guys back up here in 5, 4, 3, 2, 1. Okay, let's see here. Calvin, did you notice something that you think is going to be a helpful shortcut for this? Yeah, that makes sense too. Because when we multiply powers with the same base, you add their exponents. So it stands to reason that when you divide powers with the same base, you subtract their exponents. Like this one. Got a pencil? Z to the 32nd divided by Z to the 26th. I don't want to write all that out and start dividing out 26 Z's. So what's that going to be? Teach, teach. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1. Shh. Truman, what'd you get for that? Z to the 6th power. How many of us got Z to the 6th? Hooray! Let's do this one. A to the 19th, B to the 5th, over A to the 5th, B. What's that going to be? Teach, teach. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1. Ella, what do you think that's going to be? A to the 14th, B to the what? 4th. How many of us got a to the 14th, b to the 4th for that? Beautiful. Now, guys, there are two kinds of students out there who have made it this far. One of them is the kind of student who's like, hooray, this is easy. And you're just doing it and doing it. And there's the other one who has this like dark look on their face and is watching me because they know what I'm about to do. They can see it. They can see it. They're just waiting. How many of you are just waiting for me to do that thing that you know I'm going to do to you? Okay, are you ready? Here we go. All righty. Got a pencil? Here we go. X to the 8th over X to the 11th. Teach! There, I did it. There, I did it. How do you multiply a negative number of times? How strange. Now, of course, negative has another word that we sometimes associate with it. That's true. There's another one, too. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Bennett, I heard you mention this after the very first one. What does this wind up being? X to the negative 3. How many of you were like, boo? Yeah, what does that mean? Well, don't worry, guys. I actually can help you with this. Put your pencils down. I'm not going to actually make you write this, but I do want you to see it. X to the 8th over X to the 11th. That's 8 X's. Shh, 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 shh. 3, 4, 5, 6, 7, 8 over 11 X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if I start dividing these out, who runs out of X's first, the numerator or the denominator? The numerator runs out. So what number goes in the numerator? Not 0. Nope, it's 1. It's the same number, because I just divided everything out. But what goes in the denominator? Well, X to the 3rd anyway. That is to say, X to the negative 3rd is 1 over X to the 3rd. If you have a negative exponent, it's trying to tell you I belong in the denominator. And the reason that is Annika actually said it really well. She's like, how are you supposed to multiply something negative 3 times? And I was trying to tell her about other words that we use for negative. What was the one that I told you you hit on? And what's the opposite of multiplication? This is saying take 1 divided by 3 x's. It's 1 divided by x 3 times. So negative exponents just mean it means it goes into the denominator. Now on Canvas, you would actually fill that in with a negative 3. On Canvas, you would fill that in with a negative 3. Shall we try another? Got a pencil? Okay, here we go. M squared n to the 8th p to the 5th all over m to the 7th n squared p to the 5th. Teach! Hee hee hee. Hee 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 hee. Hee 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 hee. M to the 7th is in the denominator. Yay, Anjana. Way to crush it right out the gates. Perfect. Yes, do you have a phone on you? Wonderful. Then off you go. It's right over there. You know what's weird about Raising Cane's is low key one of the best things on their menu is their toast. Like, how is it possible? Like, I was like, why is there a piece of toast? And then I ate it and I was like, it's the best toast. It's so good. Straight fire. Okay, come on up in 5, 4, 3, 2, 1. All right, Sophie, what did you get for the m exponent? -5. What'd you get for the n? And what'd you get for the p? Ooh, I think it does have an exponent. 1? Well, hold on. Oh, it's okay. Check it out. Whoa. I'm doing it. I'm a professional. I know what I'm doing. Sophie, this is good. You know what's happening? You're overthinking it right now and you're like trying to get ahead of me. You're trying to get to a place where this is already simplified, but I'll tell you right now, don't try to get ahead of me and go ahead and subtract the exponents. What would that number be? They would be 0. Very good. Now I'm going to, yeah, right? Because 2 minus 7 is -5, 8 minus 2 is 6, and 5 minus 5 is 0. Now, do we know what p to the 0 is? Some of us might. I'm going to tell you right now, I was walking around, Anjana already has this simplified, because on Canvas, this is good enough. You would fill in the blanks like this on Canvas, and that's great. But on your skill check, I want to see this simplified on your paper. Anjana, can you tell me what this is when you simplify it? How do you think Anjana did that? How did this turn into that? Teach! Abby, did you already have that as well? May I see it? I'm gonna see if I can put you two on the start team. But you didn't put it up on over. Yes, I see.
So it's not this. It's just that what happens if the p was like p to the second power?
P to the second?
Yeah, and then where would like?
Oh, well, P was to the second. We'll look at one that does that. Okay, don't worry. I got you. Come on up in 5, 4, 3, 2, 1. I'm going to put Anjana on the start team for seeing that. That was really cool. Okay, let's see here. So I actually want to start here. Abby, you actually got rid of the P right away. Can you tell me why that was okay? Why can't I just cross out the P and forget it's there? Shh. Yeah. Guys, a number divided by itself is always 1. P to the 5th divided by P to the 5th, that's a number divided by itself. What's a number divided by itself? 1. What is anything times 1?
1.
Nope. Itself. So a p to the 0 is just gone. But how did Anjana, that's how Anjana knew she could get rid of p to the 0, because, well, let's talk about that in a minute. But, I was about to be like, how does Anjana know? I was going to draw on Anjana. Anjana already knows how she knew it. But let's see here. Camilla, how did Anjana know to put the n upstairs and the m downstairs? Beautiful. That's exactly right. Since it had a negative exponent, it belonged to the denominator, and even better, when it went into the denominator, now it has a positive exponent. This is how you simplify those. Because if it didn't, that's a great question. Someone said, why does it have a positive exponent? Put your pencils down for a second. If it didn't, n to the 6th over m to the -5th would be n to the 6th over 1 over m to the -5th, wouldn't it? Then you keep flip change, and now it's n to the 6th times m to the -5th, and it just keeps going back and forth, and like it gets stuck in a loop. The reason that is, guys, is because a negative exponent says, I belong in the denominator. I belong in the denominator. That's what it tells you every time. And we're going to look at a really heavy example of that in just a second. Let's talk. We'll talk. We're actually going to look at one like that in just a second, okay? Here's the other thing I wanted to say about that, guys, is that, got a pencil? The thing is, guys, any number to the 0 is equal to 1. And I know that's weird, because it's telling you, the reason that it is, guys, is because any number to the 0 is just telling you it's really that number divided by itself. And any number divided by itself is 1, except for one number. Well, yeah, 0 to the 0th power is undefined. You are not allowed. Well, someone says, what about pi? Pi to the 0 is pi divided by pi, and pi divided by pi is? So we're good. Totally fine. Not even a problem. Okay, let's see here, guys. Let's look at a problem that... Oh, I don't know. It depends on what you're typing in. So let's see here. Millie asked a really good question. Millie, will you ask it again, please? Okay, let's take a look at what happens when we've got a lot of this going on. Got a pencil? T to the 16th, U, V to the 15th, W to the 6th, all over T to the 7th, U to the 7th, V to the 12th, W to the 13th. Go ahead, guys. Give that a try and teach. You guys feeling good over here?
Yeah.
Good. You guys feeling good over here, table J? Love it. You guys feeling good over here, table H?
Yep.
Perfect. You think you got some ideas on how to handle those extra negatives? That's okay. Let's talk about it. Table G, you guys feeling good? Duane, what's up? That's kind of what you were asking, right?
Yeah. Also, it's just that. Wait. I forgot.
Okay, let me know when you come back with it. Here, let's get this written in here, please. I want to see that in there as well. Love it. Love seeing you fix that up. Hi, Duane. That is a good answer.
So it's just about all the letters. It's like why in like even when I go on Google and look at stuff containing variables, it's like the most common variables used are T, U, V, W, S, E.
You know what? It's a lot of that stuff in the middle is reserved. E is reserved. I is reserved. I don't like to do stuff around O because I don't like O, because O looks like a 0. I don't like doing stuff around S because S looks like a 5. I use a lot, though. I use different ones. Hi, Annika.
Positive, negative. How do we choose which ones go where?
Let's find out. Let's do it together. Okay. Can I get you guys up here in 5, 4, 3, 2, 1. Okay. Shh. Voices off, please. Anjana, I want you to tell me what this is, but don't tell me the reduced version yet. Tell me the thing that you would put in Canvas that has the negative exponents and everything. Mm-hmm. Yes? Guys, I can't hear Annika. Oh, sorry, Anjana. Beautiful. So that's what you would type into Canvas. You would put in the 9, -6, 3, -7, and that's good enough for Canvas. But to get a 4 on your skill check, when we take that this week or next, I haven't looked at the schedule just yet, we need to simplify this. And someone was asking, how do I know where to put which one? Here's what you do. You look at it one piece at a time. So, Kenzie, does t to the 9th have a positive exponent or a negative exponent? So do you think it belongs in the numerator or denominator? That's right. Does u have a positive exponent or a negative exponent? So you think it belongs where? That's right. So I'm going to write it down here without the negative. Because now it's where it belongs. Where's the v go? And where's the w go? That's all there is to it. That's how you just tuck them in. You just tuck them in at the end. Perfect. How many of us are feeling pretty good about this? Okay, guys, I got 2 more things that we have to talk about. One of them is going to make you hate me in a way you hated me earlier, and the other one's going to make you hate me in a totally new kind of way. Which one do you want to do first? Do you want to hate me like you hated me before, or you want a brand new way of hating me? How about this? Point up if you want a brand new way of hating me, and point down if you want to hate me like you hated me already. Okay, you want to hate me like you hated me already. Let's do it. Got a pencil? Here we go. 12, A, B to the ninth, C to the fourth, all over 18, A to the fifth, B to the 12th, C. T!
Challenge accepted.
Hee hee hee. Hee hee hee. Yes, actually, just barely. Do you have a phone on you?
No.
Perfect. Off you go.
What's that? Is that a 4? Oh no, that's a 9. Oh.
But I'll tell you, at least it's not too different than the way that you hated me before, right?
I should make it.
This is kind of a new. This is well. What do we do with multiplication? Yeah, the point is, it's pretty much the same thing except it's opposites, right? Okay, that's okay. Can I get you in 5, 4,
Wait, not yet.
3? Oh, you guys are. Wait, you guys need another moment?
Yeah.
Okay, 45 more seconds. I'm putting up a visual hint while you're working because I'm bored.
Oh, that was a 12.
Well, I'm bored, so I guess I'll help you.
If you gave me like 10 minutes to work on this and I wasn't thinking about something else, it would be fine.
Okay. Can I get you in 5, 4, 3, 2, 1? So, Beatrice, you were asking about what you were not sure what to do because of the coefficients in here, and then I asked you like, what did we do with multiplication? And you didn't answer me. You just said, oh, and then it got working, which under normal circumstances would be excessively rude. I'm like, I asked you a question, but in math class that totally makes sense, right? So, Beatrice, what was that? Oh, what did you think? Yeah. So I'm going to just divide my coefficients. So hooray, 12 divided by 18 is... Boo! Okay, here we go, guys. Can I get you in 5? Forget it. 4, 3, 2, 1. That's going to do it. That's going to do it. Thank you. I'm going to go ahead and recommend you give that to me as a fraction. There's several reasons that I think giving this to me as a fraction is best. The first one is if there's a repeating decimal, it makes your life a lot easier. How about your A's here? What did you get for your A exponent, Beatrice? And your B's? That is a 9, yes. And then your C's? Great. So there it is, as it should be in Canvas. I'll be right with you, Samuel. If you wanted to reduce it, guys, the 2 and the 3, 2/3, 2 in the numerator, 3 in the denominator, where should the A go? Upstairs or downstairs? It should go where? Downstairs. Where should the B go? Downstairs. It's a negative. Where should the C go? Upstairs. It's a positive. That would be your final answer as far as a reduced answer goes. Samuel, got a question for me? Except I can't hear Samuel, table H. Because they're coefficients, it's like, if you have 12, that's equal to 6 times 2, right? And 18 is equal to 6 times 3. So the 6's divide out and leave only 2 and 3. It's because there's all these little numbers in between. It's kind of like how when we had our coefficients in front of our multiplication signs, then we had to actually just multiply those, okay? Perfect. And then with division, you got to divide. Are you guys ready to hate me in a brand new way? Hooray! Here we go. I'll be right with you. Got a pencil? Negative 6. Let's do no, stop it. I'm just trying to I'm trying to do something to kind of mix it up a little bit. Here we go. F to the negative third, G to the eighth, H to the negative 1, all over 15F to the negative 10, G to the negative 2, H to the 7th. That's an H to the negative 1 on the numerator. Go ahead, guys. Teach. Leo, let's get back to our assigned seat. Work with those guys. Okay, go ahead. Let's get this one in there. Let's get some notes in, okay? That's not really enough for me. Hi.
Why can't we like because
Be right with you.
right here. If it's negative 6f over 15f, why can't we just go negative 6f minus 15f?
Well, because it's not. It's because of the nature of coefficients. It's because negative 6 isn't a power, right? It's not an exponent. It's just a number. Negative 6 is another way of saying negative 2 times 3, right?
Yeah.
And 15 is just another way of saying 5 times 3. So what you're actually dividing out are these 3's. The 3's are what are disappearing, leaving this behind.
And that's what happens when you go negative 6 over 15.
Uh-huh. Yeah, go ahead and punch it in there. They'll give you your negative 2/5.
What does that do?
There you go. What's up?
I don't know.
Okay, let's go ahead and keep going. Let's talk to your partner and see what you can manage. Okay. Can I get you in 5, 4, 3, 2, 1? Mo? Mo, do you want to help me with the coefficients or with the variables? Gentlemen. The coefficients. What am I going to do with negative 6 and 15? You're just going to divide them. Now, if the answer is something that you don't really like, negative 6 divided by 15, I'm going to recommend that you put it in as a fraction. That's negative 2/5. Love it. Negative 2/5. That makes me happy. I can live with that. Okay, let's see if I can get a little bit of help then. Millie, how many F's do I have? Negative 13? Careful. How did you get that number? Let's punch that in and make sure that's good. I know that there was that minute where we did all those subtractions, but negative 3 minus negative 10 is actually positive 7. That's okay. Millie, for what it's worth, I'm actually really glad that you made that mistake because it's a powerful illustration of, I know you know that, right? We've tested on that. You killed that test. But the thing is that when we have all this stuff flying around, it's really easy to get lost. So what would that give us for our 8? What's our 8 minus negative 2? That's okay. She's on it. 10. What's negative 1 minus 7? Yeah, punch it in there. Beautiful. And in the interest of time, guys, to simplify that, the negative 2/5 shows up as a fraction. F goes upstairs or down? F goes upstairs. G goes upstairs. And H goes down. There you go. Guys, on your planner, right before you go, page 52, Monday, November 3rd, there is 8.2 dividing power expressions. Make sure you get that written down, and we'll see you guys next time, okay? I heard it, Rex. What's the question? Okay. Hey, Sina, hang on. Let me just turn off these guys on the internet. Do you guys want to say anything? Do you want to say anything?